We're doing another problem in substitution reactions. So let's write this down so we know what we're doing, right? So substitution, this is Sn1, Sn2. So let's see, we're solving a problem actually that students gave to me. So thank you for that suggestion. So the problem is the following. We have this structure. That's, I start from here, and then it reacts with this dihalide. And the problem said that it gives you a product that has 4 carbons, 8 hydrogens, 2 oxygens, and that you form sodium bromide, 2 molecules. That's your data. So let's do the analysis of that and see what's happening, how we can get the product. So first, let's see, the substrate, remember, this is ionic, this is negative, this is positive, negative, positive. So sodium is just the counter ion. And this is like an alkoxide, essentially. And those are very strong bases, strong nucleophile. So that's what we have, a strong base, analyzing the reagent, and here, strong base, strong nucleophile. Now this is my alkyl halide. And we see the alkyl halide, and I said the molecule is symmetric, so what I say for, okay, I'm back here, I got locked out, but okay, let's continue doing what we were doing. So I was saying that this molecule is symmetric, so what I say about this carbon is the same for the other, right? So this is my alpha carbon, right? And it has attached one alkyl chain. So that's a primary alkyl halide. Same goes for that. So those are excellent for Sn2 reactions. So this is my nucleophile. That is my alkyl halide. And we're going to do now one substitution. So first thing we're going to do then is we do the nucleophilic attack over to my alpha carbon. And simultaneously, we know this is a concerted process. Bromide is going to the part. So let's draw the intermediate, the first product. It's not yet what we want, but we're going there. So now I have this is still my bromide, but here I am going to have the oxygen in place of where the bromine was, and I have 1, 2 carbons, so 1, 2 carbon, and I have another oxygen, and this time I'm now drawing the counter ion. So again, notice that we have, I'm counting carbons to keep track of that. So 1, 2, 3, and 4. All I did is a nucleophilic attack, and we have displaced one bromine, so I already have 1 molecule of sodium bromide. Next, what's going to happen is an intramolecular substitution, Sn2 again, but now the nucleophile and the leaving group are in the same molecule. My alpha carbon is here, where the bromine is. So I'm going to have that same thing, my attack from the back side. So this attack on my alpha carbon is simultaneously, this is departing. So nucleophilic attack, loss of leaving group. And we're going to finally have the structure of what we have here. Notice that I have, say, 1, 2 carbons, 1, 2 carbons, and an oxygen. So notice these 2 carbons here and the other 2 carbons. So if you count, this is the molecular formula exactly of the product that we want. And in the second attack, we have produced the second molecule of sodium bromide. One thing that I wanted to mention here is why do we have the second attack being intramolecular and not another molecule like that attacking? Why do we have that? The second as an intramolecular attack. So for that, we're going to look at the entropy change in this reaction. Notice that when we have say, two things, two molecules, and they are being combined into one, there is a decrease in entropy. So now, if you had in the second step this and have an attack, say that I have this, I'm going to call my intermediate. And that's A. If I have a molecule, an external molecule, another of these, attacking A, I will have a decrease of entropy. However, if the attack happens internally, there is somewhat a decrease of entropy because it is restraining the movement, forming a cyclic structure, but not as much. So in this process, entropy, even though it decreases much less. So the intramolecular attack is favored over the intermolecular attack if I did the external nucleophile. So this will have a greater negative entropy change as opposed to this one. That's why we have the intramolecular attack, and that's the formula of the compound we want to make.